So looking at our module from the beginning, our learning unit 1, so learning unit 1 is just an overview of regression analysis, so there is nothing really new after having done our STAs. So it's just a refresher in terms of what we have covered. There is a bit of theory where we talk about why it's important for us to study econometrics, what are the uses, what are the major foundations, and we talk about regression analysis and the meaning of each component in a typical regression equation. So first section, we talk about what are the important concepts in terms of econometrics. What is econometrics? So when you're talking about econometrics, we can say to explain what econometrics is about, one can look at its goal, its method, and its uses. Econometric approach is represented schematically in figure 1. Goal is an estimation of economic relationship. Method is mainly through regression analysis using actual data. So we said we need goal, method, and use. So goal, we are saying to estimate economic relationships through regression analysis by using actual data. Economic models are used mainly for describing economic reality, hypothesis testing, simulation, and forecasting. So that would give us a working definition for what econometrics is all about. So econometrics makes a bit of use from the following disciplines or departments or branches: economic theory, economic data, and statistics. So it is a kind of a combination of those. Economic theory that we're talking about, we talk about relationships, for example, the demand curve, which follows a linear form where we say price is equal to A, which is a constant, plus beta, B times quantity demanded. Consumption function, we talk about the consumption function given by C is equal to C plus CY, where your C is your autonomous consumption, small letter c, marginal propensity to consume, and Y is your income, giving us induced income. So in the previous modules, we both were treated in a theoretical fashion. These coefficients, that is A and B in the demand equation, we assume to have some predetermined values. To be of real use, however, one requires to accurately estimate these particular coefficients. So econometrics provides methods of estimating these coefficients using actual data. So we have this schematic about econometrics where we are saying the method or inputs are going to be economic theory, and then how do we estimate, what are the uses? So that will be method, goal, and uses. There's still a bit of theory where we talk about the background, economics, economic data, economic theory. We go also and talk about statistics. How do we use statistics? But what we need mostly would be what are the uses of econometrics. So in here, we need this part mostly. 5 uses. Firstly, it aims to coordinate econometric models to various components to help forecast international trade and capital movements. Most central banks have that. These are mostly simultaneous current inflation. I want a part, uses an econometric model to forecast inflation. So that should be another use. Department of Finance uses econometric to forecast tax income and to simulate the effects of alternative policy options. Commercial banks use econometric models to better understand how different economic sectors and industries may react to shocks in the economy. Simple type of models may be used by business and industry for forecasting and planning. So this is part of what we are going to talk about in terms of what we are going to do with our econometrics. But what we need as well on the textbook, they summarize it better because it says it has 3 major uses. Firstly, we describe economic reality. We test hypotheses about economic activity, economic theory, forecasting future economic activity. So you notice that in terms of the static guide, mostly it has to do with forecasting, but that's not the only thing. We still have these other ones where we talk about describing economic reality. Testing hypotheses about economic theory, forecasting is also part of our uses of econometrics. Structural analysis, we are talking about the consumption function there. Policy evaluation, we can also use it for policy evaluation, forecasting. And next you go on and talk about regression analysis. So you were given a linear equation as follows, where y, the dependent variable, is described by this independent variable, but it does have an intercept term. So we have x1 explanatory, x2, x3. These are our explanatory variables. They are explaining this particular dependent variable. Estimated and true regression equation. So normally the estimated regression equation, we have a head on top, we call that y head, and the true one would just be a y. So if it's like this, it would normally mean this is your true equation. If it is just a beta like that, and a beta 2, beta 3, and so on, it would mean this is the true beta. If it's an estimated beta, it would have a head on top like this one over here. So just remember, beta would be the true, and then with the head, it would be the estimated one. We can use a simple linear regression model to estimate the weight based on height. So that would be more like our BMI index, but we are just using one explanatory variable for weight. We can have another model that talks about price of a particular house, can be a function of size. So we are only having one explanatory variable, which is size. We can have more things like location. We can have more things like, besides location, maybe the population density in that area. Is it a coastal area? Is it not? And so on. Those would be different explanatory variables. So in this instance, we only have one x1 variable, which is our size. So to illustrate the different variables that we can have to explain housing prices, we have a question here where we say consider equation 23 in textbook. Price is given by, this is the intercept term, and then 0.138 times the size. So that would be our regression equation for this particular model. So there's a few questions that you would have to ask in terms of you're asked in terms of that, and then there's just a part of paragraph questions. So you need to take these paragraph questions seriously, because this is the typical things that you are examined on. You get this a lot in your exam. First one says, explain the goal of econometrics and its three main uses. Explain whether the specification of a regression equation is mainly objective or subjective. Provide an example. Explain the nature of a linear regression model. Use standard notation. And explain meaning of dependent and independent parameters, difference between causality and correlation. So we should have something in terms of causality and correlation on our textbook, but causality would simply be a situation where we are saying A causes B, or B causes A, something causes the other thing, and then a correlation, we are going to talk about this in our serial correlation part, where we are saying if A behaves in this way, B behaves in a particular way, but there doesn't necessarily need to be a causality running between them. It's not like A is causing B or B is causing A in any way, but they are behaving in a particular direction together. So we can talk about normally if maybe outside temperature or the weather goes up, people, or in summer, I can say in summer, people wear shorts. So if you see like the number of shorts people are wearing goes up when it's summer. So, but in terms of, so that would be, there is a correlation between summer and wearing of shorts, but it doesn't mean that people wearing shorts causes summer. So yes, there is correlation between them, but it doesn't imply causality. In terms of our textbook, we talked about the uses of econometrics. We have a quantity. This is the demand equation. We are saying quantity is a function of the price of substitutes and your disposable income. So these are the explanatory variables that we have given. Alternative econometric approaches To get a better picture of this, I would just look at the steps used in non-experimental quantitative research, so that is just a bit of theory. What is regression analysis? We talk about dependent variables, independent variables, and causality. So dependent variables is the one that you're trying to explain. In this case, we are talking about quantity demanded of a particular product is a function of price, so this would be independent. Price would be independent. Price of substitutes independent. Disposable income independent. Causality, you need to have an idea about the cause and effect relationship between certain things. Seeing the equation linear models, that's the one. And then what does it look like if it is a linear model, a straight line? Otherwise, if it's like this, now it's a polynomial or a quadratic equation. It is a different functional form from a linear one. Slope of a particular equation is represented by beta 1. In this case, that is our beta 1. Is always calculated as your change in y over change in x, where you separate your x, y2 minus y1 over x2 minus x1. Stochastic error term, we say it's a term that is added to a regression equation to introduce all the variation in y that cannot be explained by the included x's. So we understand that in terms of the price of a quantity demanded, you can say it is a function of beta 0 plus beta 1 times, let me talk about the house price. We said it would be a function of size. But that is not the only thing. So we are going to add an error term to take into account all the other things that we could have mentioned, all the other explanatory variables or all the other x's. This would be x1, x2, x3, x4, xn, and so on. We could have included them, but we did not. So we put in an error term to take that effect into account, all those ones that we did not include, or any other explanations that we can have explaining the price of a house. Stochastic error term must be present in a regression equation because there are at least 4 sources of variation in y other than the variation included in x. So that is the reason why we are going to have stochastic error term. Linear functional form, non-linear relationship, we've mentioned a bit about that. Extending the notation, we can have n different observations for a particular study, meaning of regression coefficient beta 1. So we would say by how much, we're saying this equation, like meaning of beta 1 in this equation is the impact of a 1 unit increase in x1 or the dependent variable y holding constant x2, x3 and all other variables. Similarly, beta 2 gives the impact of a 1 unit increase in x2 holding the other ones constant. So we are saying if this is 0.7, if x1 increases by 0.7, y would also increase by 70% or 0.7. Multivariate regression coefficients, it can have a situation like this where we're talking about the age. It is a function of expenditure, education, like and gender. That is different variables that we can include to estimate, to represent a wage that someone is going to earn. Estimated regression equation, we can have one, and then we have the error term. Don't forget our residual is represented by the actual observations minus the estimated observation. What else do we need? We have a diagram there talking about our error term. Simple example of a regression analysis. There is an example there that you can look at to understand what we are talking about better. And using regression to explain housing pricing, that is what the example that we looked at. So that should be towards the end. And then we are going to have a question and answers at the end. So that is basically our study unit 1, introducing us to regression analysis.